Hey everyone, welcome to the recap video for the April 13th MTRW algebra lesson. So in this video, we'll talk about homework 10, which you guys just got back, and then we'll talk about lessons 162 through 164. And with whatever time we have left, we'll wrap up that worksheet that we started last week, but we're finishing up this week. Okay, so let's just get started with homework. So homework 10. I'm just getting, bigger size. So the first question I wanted to talk about was number 10, and just to recall, the homework is from lesson 158. So problem 10 involved simplifying this expression. And in general, everyone did really well on this problem. I just wanted to go over it because there was an easy strategy that would have been less work and also less easy to make mistakes that not everyone showed. So I just want to make sure everyone sees it. Okay, so this is the initial problem that we have to simplify. And everyone started off the same way. I think we wanted to get rid of that minus. So I'm going to just rewrite everything as an addition, basically. And this is where a lot of strategies started drifting apart. So most solutions I saw just went from left to right. So we'll take this minus 15.6 and we'll subtract 7.31 from it, get something like minus 22.9. And then we'll add this 5.6 and so on. But some of you guys observed that we have a minus 7.31 and then we have a positive 7.31. So if these were next to each other in the expression, we could have easily canceled them out. So how do we move them next to each other? We're going to have to use the commutative property of addition. So let me just mark that down. Last time I know we talked about the commutative property of multiplication. And it's been a while since we've seen the commutative property of addition, but just because we haven't seen it in a while doesn't mean we can't use it. So if you see an opportunity to use this property and it'll make your solution better, by all means, please do it. Okay, so the two terms I'm going to commute are, I'll do these two. I know in class I switched two different ones, that's fine. So I have 15.6. And now I have a plus minus 7.31, plus 7.31, plus 5.6. So I just switched the positions of the last two. And now I want to cancel out these two terms in the middle. So canceling them out involves doing this operation in the yellow parentheses first. And the associative property of addition tells us we're allowed to do that. Okay, so by the associative property, these two get canceled out, and we're left over with minus 15.6 plus 5.6. And this is a relatively straightforward operation. We get minus 10. That's our answer. Okay, so that was question 10. I just wanted to emphasize we have these tools that are really helpful in order to help us make fewer mistakes and to do our work faster. So pretty much anytime you see two of the same number but with opposite signs, we can cancel them out. Okay. Next thing, we're going to talk about question 15. So I think in general you guys did well on this question too, but there were some common mistakes that I wanted to point out. So this is saying, my friend and I, actually, why don't you just look in the book? I don't want to bother writing out the whole question. Okay? But the general gist is that you and your friends start out with the same number. I subtract 20.8 from my number, and my friend adds negative 6.2. And if we add together what we got from those operations, we get 27. So every time we see these kind of secret number or mystery number questions, the first thing I want to do is to set up a variable to represent that number. So in this case, my variable I'm going to call x. This is going to be my friend's number / my number at the beginning. Okay, and the question says I subtract 20.8 from my number, and my friend adds minus 6.2 to her number, and these two added together give me 27. Okay, so I'm going to actually just simplify the left side first because we can combine the two x's and we can combine the numerical parts. So we have a minus 20.8 minus 6.2. This gives us minus 27. If you're not sure, now is a good time to pause the video and check why. The right-hand side I have not changed at all. Okay, so now I want all my variables on one side and all my numbers on the other side. And the way I'm going to do this is to add 27 to both sides. And the last thing to do, I need to get x by itself. So to undo this 2 times x, I'm going to divide both sides by 2. I'm going to get x is equal to 27. Awesome. So for those who set up the question with the variable and solved for x, fantastic job. The biggest common mistake that I saw is this. So I saw work that just looked like 27 minus 20.8 plus 27 plus minus 6.2. This equals 27, so boom, we're done. Okay, this is a check. This is not really a solution. This checks that 27 works, but we don't know how we got 27. For all I know, you guys could have guessed and checked hundreds of values, or used a calculator, which you're not supposed to do in your homework, and I wouldn't know from the solution unless you show all the steps, like in the previous thing that I wrote down. Okay, so I see a lot of this. If you actually did use guess and check, be honest and just write down all the guesses that you made. I'd rather see that than just the fact that 27 works for this question. Okay, so I'm going to zoom out, and you can pause here if you want to review the homework. Okay, cool. So now on to lesson 162. Let me just check. Cool. Lesson 162, it's about dividing rational numbers. So we care about expressions that look like a divided by b, where a and b are both rational numbers. Okay? So like last time, I'm going to set up a table, and I'm going to let the rows be for a and the columns be for b. And I want to know what happens when a is positive and when a is negative. And I also want to know what happens when b is positive and b is negative. Okay? So let's first talk about this square, where a is positive and b is positive. This means we're taking a positive number dividing by another positive number. This is nothing different from what you guys have done before with division. So we still get a positive number. Before, we never had to deal with signs. Now let's talk about these two. Okay, so these two squares correspond to cases when a and b have different signs. So a is positive, b is negative, or a is negative, b is positive. And in this case, your answer will take on a negative sign. Okay? And the very last box you need to worry about is when both of these are negative, and it turns out that actually your quotient, the answer that you get, is going to be positive. So some of you guys might already notice that this is the same exact table from last lesson, from the multiplication of rational numbers. Why is that the case? Well, one fact is that division is multiplication by the reciprocal. What do I mean by that? Reciprocal is a fancy way of saying the flipped fraction. So if you originally start with a fraction like 1/4, then the flipped fraction will be 4/1. Okay? So a divided by b is the same exact thing as a times 1/b. And when I take 1/b, I don't change the sign of b at all. So if the sign of a is negative and this sign of b is positive, for instance, I use the same table because I end up doing multiplication. Okay. So let's run through an example of this, just to lock it in. So an example from the textbook. Let's look at -2 1/3 divided by -0.7. Okay. So the first thing I'm going to do is to actually write both of these as just normal fractions. This is a mixed number and it's really hard to do multiplication and division with it. This is a decimal, and if the other quantity isn't easily written as a decimal, I'd rather turn it into a fraction. Okay, so -2 1/3, that becomes -7/3. This is 2 1/3. And I'm dividing this by, I'm going to write -7/10. This is coming from -0.7, which is 7/10. Okay, and now we know that when we divide, it's the same as multiplication by the reciprocal. So I'm going to change it to multiplying by -10/7. And this is great news because I can cancel out that 7 from the numerator and the denominator. And at the very end, I'm left with 10/3, and now I have to decide what sign to put on. Well, both of these terms have a minus sign, so I'm going to leave a positive sign, or just write no sign at all. And I told you guys in class, but I'm really happy, like, I generally don't care if you leave your answer as an improper fraction. As I mentioned before, mixed numbers are hard to work with, and a lot of times we end up converting them into improper fractions anyways. So if you want to leave your answer as 10/3, that's totally fine by me. Okay, so this is a review of lesson 162. It's pretty, of the 3 lessons, it's probably the most straightforward. A lot of similarities from this lesson and the ones we saw last week. If you want more examples, the book has a lot of good ones. Okay? In that case, I'm going to move on to lesson 163. So lesson 163 is about the distributive property again. But with division instead of multiplication. And let me just write the property down. If I have a plus b in parentheses divided by some rational number c, it's the same as if I took a divided by c and added it to b divided by c. Okay? And one thing we need to be careful of is we need to say that c cannot be 0. That's because we can't divide by 0. So every time you see an equation using variables and a variable is being divided, you have to write things like this down. Otherwise, the equation doesn't make too much sense. Okay, so looking at the distributive property for division, it looks so much like multiplication. I literally could have replaced the division signs with multiplication signs here, and it would have been exactly the distributive property for multiplication. And again, this shouldn't be a surprise because division and multiplication, you can switch between one and the other really easily. So the statement that I wrote in yellow is equivalent to this statement in blue, a plus b times 1 over c, right? So I mean, these two are equal between the yellow and the blue. Okay, and this blue expression I can now simplify. Actually, I'm going to move this a little bit. Great. This blue expression I can simplify using the distributive property of multiplication. So I get a times 1 over c plus b times 1 over c, right? This is what happens when I distribute that 1 over c. But actually, this is a fancy way of writing a divided by c, right? And this is also a fancy way of writing b divided by c. So I actually get that the right-hand sides also match up. Yeah, so we could have derived this top equation just from applying the distributive property for multiplication. So let me just mark that we used the distributive property of multiplication here. Okay. So every time we see something new, we always want to look at some examples. Let's do one example where this property makes your life so much easier. So this is example 6 in the lesson, part C. So if I remember correctly, it's minus 18.3 divided by minus 5 plus 3.3 divided by minus 5. Okay, so I'm going to look at the expression that I'm supposed to simplify here and look at my distributive property with division. And it turns out that my expression matches up a lot more with this right-hand side than it does with the left-hand side, because there's a plus joining two separate divisions. So here we have a plus joining the two separate divisions. And this is telling us we want to apply the distributive property from right to left. We want to rewrite our expression so it looks like something from the left. Okay, so this involves pulling out this common term c. In this case, c is minus 5. It's shared between both division operations. So I'm going to pull out that minus 5. And what's left over, I have a minus 18.3. And I have a plus 3.3. So now this is telling me, okay, you do parentheses first. Let's add these two together. Oops. My mistake. I should have pulled it out as a division. So for those who caught it, good job. Okay, so these two add up to minus 15. Then we divide by minus 5. Okay, so the number part is going to be 3. Now we have to figure out the sign. But we have two minus signs, and we saw before that two minus signs, they cancel out when you divide. So we just get 3. If we didn't use the distributive property, this would have been a disaster. I would have had to do minus 18.3 divided by minus 5 first. And this involves doing, 18.3 divided by 5. And this doesn't really go in that nicely. It does take a lot more work. I could have been making a lot more mistakes on the way. Right? And I also end up working with numbers that are a lot uglier than minus 15, right? So if you see an opportunity to use the distributive property, definitely go for it. And now is a good time to pause if you want to review lesson 163. Okay. Oops. I should add a new page to this. So let me do that real quick. Actually, I'll just use an old page. 1 me just erase everything. This is now lesson 164. So this just goes over a few properties involving absolute value. Okay, so property number 1 concerns multiplication of rational numbers. So if I take two rational numbers and I multiply them, and then I take the absolute value, I'm going to get the product of the absolute value of A with the absolute value of B. Okay, so this is a good time if you're confused to pause and maybe try some examples of different values of A and B and check that the two sides of the equation match up. But a simple explanation for why this happens is on the left-hand side, we're taking this product, and when we take the absolute value, we're chopping off any signs, any negative sign that might be there. So we're forced to end up with a positive number. And on the right-hand side, instead of chopping off the negative sign after we do the multiplying, we're just going to chop off any negative signs before we multiply together. So we end up multiplying two positive numbers together, and we'll still get something that's positive at the end. Really similarly, property 2, it's going to be about division. So if I have A divided by B, it's the same as the absolute value of A divided by the absolute value of B. And for the same reasons that this worked for multiplication. Okay? So these two properties are relatively straightforward. I'll leave it to you guys to try some examples on your own. It's probably most helpful to pick examples. So try examples when A and B could be negative. Okay. Let's make a side note. This type of thing doesn't work for addition. And we'll see, we saw actually in the quiz, why not? We saw that when A and B have opposite sign, actually A plus B is not equal to the absolute value of A plus the absolute value of B. But there is a statement that's always true. So the statement that's always true is that the absolute value of A plus B is always less than or equal to the absolute value of A plus the absolute value of B. So this type of thing you might see in the future. This is called the triangle inequality. Why does triangle come in? Well, in a triangle, it's similar to the idea that in a triangle, when you add any two of its edges, the sum of the lengths has to be longer than that third edge. This is something you might see in geometry. So even though this blue statement is not always true, we still get something really nice in the yellow statement. All right, I'm going to take this time to zoom out, and you can pause the video and recap the key points from lesson 164. Okay, moving on. Let's talk about the worksheet. Okay, so in this worksheet, last time we started off with the condition x is greater than 3. So we only care about x's that are bigger than 3, or to the right of 3 on the number line. And the first question wanted to mark 3 possible values of x. So I've actually marked 4 here. I chose 3.0001, which is very close to 3. Then I picked 4 and 10 that are kind of medium distance from 3, and then I picked a googol, which is very far from 3. Okay, so question 2 is saying, if we multiply every value we chose by 2 and plot the new number line, what do we notice about it? So I took all my values, like this 3.001 multiplied by 2, get 6.002. I get 8, I get 20, and I get 2 googol now. And I noticed that all the values are always going to be bigger than 6. And in fact, even if I chose a number that was so close to 3 in question 1, I would still be slightly above 6 in question 2. So question 1 we considered x. And in question 2 we considered 2 times x, like what happens when we multiply x by 2. And in question 3 they want an inequality that sort of sums up what happened. So in one sentence we wrote, if x is greater than 3, so if we picked a number that was okay for question 1, then 2x, when we multiply it by 2, it's always going to be bigger than 6, no matter what x is. Okay? And this is really nice, actually, because this looks a lot like what would work for an equation. So if I had an equation, instead of an inequality, I had something like x equals 3. If I multiply both sides of that equation by 2, I would get 2x is equal to 6. And I can go back and forth between these two. They're telling me the same information. So, for this question, we started off with x is greater than 3, and it looks like we can multiply both sides of this inequality by 2, and we would get 2x is greater than 6, and we keep that inequality in the middle, right? So this is kind of telling us, okay, this multiplication by 2 at least, it looks a lot like how we would manipulate equations. Okay, so for question 4, now we want to multiply every value we chose in number 1 by minus 2. And then I want to plot the numbers on a number line. Well, this is relatively easy because we already did question 2. That was multiplying by 2. Here we're multiplying by minus 2. So we're just going to take that number line from question 2 and flip it. So now I have minus 6.0002. I have minus 8, which now is to the left of minus 6.002. I have minus 20, and I have minus 2 googol. Okay? And now we notice, okay, all of our numbers, they used to be bigger than 6, but their negative versions are all smaller than minus 6. They all appear to the to the left of minus 6. So if we want to write an inequality that describes what happens here, is that when we multiply x by minus 2, the number we get is always less than minus 6. So this actually, we have to be really careful here because the sign flipped. Originally we had x is greater than 3, now we have minus 2x is less than minus 6. Okay? So finally, we want to write a rule that sort of sums all this up together. And the rule tells, the rule that we might notice is that when we start with an inequality and we multiply both sides by a positive number, we keep the inequality in the middle. And when we multiply both sides by a negative number, we have to flip that inequality. So let me just write that down. When we multiply both sides of an inequality with a negative number, we flip the inequality. So greater thans become less thans. So you might be asking now, why is the equal sign unaffected? And my teacher, when I was in 6th grade, she would tell us, you know, the equal sign, when you're multiplying both sides by a negative number, it does flip. But when you flip an equal sign, you just get another equal sign. So it doesn't look like it does. But secretly it is. Okay, so I'm going to zoom out now. And now's a good time to pause if you want to review the whole worksheet. Otherwise, that's it for my recap. Thank you guys for listening.